Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Resonance energy is the difference between the theoretical, expected, heat of hydrogenation and the observed, actual, heat of hydrogenation. A more stable, resonance-stabilized, compound releases less heat upon hydrogenation than expected. Moving on to the next step. Understand the reference compound. Cyclohexa 1,4-diene has two isolated, non-conjugated, double bonds. Its observed heat of hydrogenation is x kcal-mol. Since the two double bonds are isolated, no conjugation resonance, each double bond contributes x/2 kcal-mol upon hydrogenation. Moving on to the next step. Calculate the theoretical heat of hydrogenation for cyclohexa 1,3-diene. Cyclohexa 1,3-diene also has two double bonds. If these were isolated, non-interacting, the expected heat of hydrogenation would be the same as for cyclohexa 1,4-diene, i.e., x kcal-mol. However, the question states the theoretical value should be based on the isolated double bond reference. Since cyclohexa 1,4-diene with two isolated double bonds gives x kcal-mol, the theoretical heat of hydrogenation for cyclohexa 1,3-diene, treating its two double bonds as isolated, is equal to x kcal-mol. Weight re-examining, cyclohexa 1,4-diene has two isolated double bonds and gives x kcal-mol total. So per double bond is equal to x/2. For cyclohexa 1,3-diene with two double bonds, theoretical delta H is equal to 2 times x/2 is equal to x kcal-mol. And for the final step, observed heat of hydrogenation of cyclohexa 1,3-diene is equal to y kcal-mol. Resonance energy is equal to theoretical delta H, observed delta H is equal to x, y. Now, x, y is equal to 2x2 y, which matches option B 2x2 y. Why other options fail? A. 3x2 y. This would imply 3 double bonds worth of theoretical energy, which is incorrect for a diene. C. 3y2x and D. 2y2x. These subtract x from a multiple of y, which reverses the logic, observed minus theoretical instead of theoretical minus observed. Therefore, the correct answer is B. Therefore, the correct answer is option B.